On a flooded coal mine in eastern China, more than 1 million solar panels stretch across the water. The reflections look endless, like a floating city made of glass. This is the world's largest floating power plant, and it just went live. China just launched a floating solar city, and the United States can't compete. For years, experts said solar farms belonged on land. China disagreed. Instead of building on deserts or rooftops, it started covering its old mining lakes with panels, turning industrial scars into clean energy hubs. The result is staggering. The Fuyang Floating Solar Project spans over 5 square kilometers. It delivers enough power for hundreds of thousands of homes, while fish farms operate beneath its shadow. Some call it a dual-use miracle. Power above, life below. Across the Pacific, America's biggest floating solar plant fits on a single reservoir in New Jersey. It's a fraction of the size. Why the gap? How did China move from coal pits to floating power cities in less than a decade, while the US still struggles to scale its first large installations? What makes these vast solar islands possible, and what does it mean for the future of global energy dominance? Today, we'll uncover how China's floating megaprojects are rewriting the map of renewable power, and why the race isn't about sunlight anymore, but surface area. Because this story isn't only about clean energy. It's about speed, ambition, and a nation's ability to turn wasted land into the next frontier of power. Welcome to Fuyang, Anhui Province, the birthplace of the world's largest floating solar city. China's path to building the world's largest floating solar city started where few expected, on the wreckage of its coal industry. For decades, provinces like Anhui and Shandong were carved open by massive coal mines. When those pits collapsed or flooded, they left behind thousands of square kilometers of useless waterlogged land. Farmers couldn't use it. Builders couldn't touch it. But engineers saw an opportunity. In 2017, China Three Gorges Corporation, the same company behind the world's largest hydroelectric dam, tested a bold idea. What if those flooded mines could host solar panels instead of sinking deeper into decay? That year, CTG completed the Huainan Panji floating solar farm. At 150 megawatts, it instantly became the largest floating solar plant on Earth. Panels floated on high-density plastic pontoons, their electrical cables running underwater to nearby substations. The lake's calm surface made anchoring easy, and its proximity to existing transmission lines made grid connection simple. What looked like a risky experiment soon turned into a template. The panels stayed stable through monsoon rains, high winds, and seasonal floods. Maintenance crews could walk across floating walkways to inspect modules, no heavy machinery needed. Performance data showed something surprising. The cooler environment above water boosted panel efficiency by several percent. The message was clear. Floating solar worked, and China had the perfect geography to dominate it. Over the next few years, the technology scaled fast. By 2020, another state-owned giant, Huaneng Power International, unveiled a new milestone: the Dezhou Dingzhuang Floating Solar Project in Shandong Province. This plant covered 320 megawatts of panels, split into 2 phases, and connected to a 100-megawatt wind farm plus an 8-megawatt-hour battery. Together, they formed a balanced, renewable hub capable of delivering steady output even during cloudy or low-wind periods. This hybrid-based model, combining solar, wind, and storage within one grid cluster, solved one of renewable energy's biggest issues: stability. When the sun dips, wind often rises. When both drop, batteries fill the gap. By pairing technologies, China showed it could not only build renewables fast, but also make them reliable. In 2021, Dezhou's performance results confirmed the vision. The project generated more than 500 million kilowatt-hours in its first year, displacing over 200,000 tons of coal and cutting hundreds of thousands of tons of CO2 emissions. Local fishermen continued their livelihoods beneath the arrays. But this was still a warm-up act. Behind the scenes, engineers at China Three Gorges were already designing something much larger: a power station so vast it could be seen from orbit. In late 2023, the Fuyang Floating Solar Project came online in Anhui Province. Its numbers dwarf every project before it: 650 megawatts, 1.2 million solar panels, and more than 85 million float elements, spread across an area of water larger than many entire towns. It's part of a wider 1.2 gigawatt renewable base that links solar, wind, and energy storage into one continuous system. At full capacity, Fuyang generates roughly 700 gigawatt-hours of electricity per year, enough to power 500,000 homes while reducing water evaporation by up to 60% on the surface it covers. Underneath, fish swim in the shade of the panels, part of a carefully designed aquaculture system known as fish PV. It's a perfect example of China's new approach to energy, reusing damaged landscapes, co-producing food and power, and creating jobs in the same footprint. Each floating array is more than just infrastructure. It's a symbol of transformation. The same lakes that once fueled the coal era are now fueling the clean one. And as these shimmering grids expand across China's waterways, one thing becomes clear. The country isn't just building solar farms. It's building floating cities of power, vast, silent, and unstoppable. Standing on the surface of Fuyang Lake feels like standing on a mirror. Panels stretch in every direction, an endless blue grid floating on calm water. But beneath that calm, there's a complex web of engineering holding everything together. Each of the 1.2 million panels rests on a high-density polyethylene float. These floats lock together like puzzle pieces, forming long, flexible rafts. They're light, corrosion-resistant, and strong enough to carry the panels, wiring, and maintenance walkways for decades. The entire platform is tethered by anchors drilled into the lakebed. These aren't simple chains. Engineers use a mix of helical anchors, catenary lines, and tension cables designed to handle rising water levels and seasonal floods. When the surface rises in summer, the cables stretch. When it drops in winter, they relax. The whole system moves as one, but never drifts. Above the surface, the electrical layout is just as clever. Instead of mounting inverters on land, technicians install them on floating islands connected by waterproof cable trays. Flexible loops in the wiring absorb changes in water level, preventing stress on the cables. Every signal, voltage, current, temperature, and wind speed, is monitored by a digital control system that reports back to CTG's central control room hundreds of kilometers away. The payoff for all this complexity is simple: higher performance, less maintenance, and zero land use. Floating solar avoids land rights disputes, deforestation, and dust buildup that can degrade panels on desert sites. The water's cooling effect keeps the panels at an ideal temperature, improving efficiency by up to 10%. And by shading the surface, the panels slow evaporation, a crucial benefit in regions that rely on reservoirs for irrigation and drinking water. But engineering on water brings new problems too. Humidity, corrosion, and wave motion can damage equipment faster than land-based systems. That's why Fuyang's developers used marine-grade connectors, UV-resistant plastics, and double-sealed junction boxes. Every joint is built to survive decades of wind and rain. At larger scales, like China's upcoming Kenli Open Sea project, the engineering takes an even bolder turn. Instead of plastic floats, the offshore arrays stand on steel truss platforms supported by piles driven into the seabed. Each section is raised slightly above the waves, allowing air to flow beneath the panels and reducing salt buildup. The structure connects through 66 kilovolt submarine cables to an onshore substation, the same voltage level used by offshore wind farms. In short, China is taking the lessons of offshore oil and wind engineering and applying them to solar. This combination of civil, marine, and electrical design is what turns a floating farm into a floating city of power. And because each project is built by state-owned giants like China Three Gorges and CHN Energy, the scale is staggering. They can mobilize thousands of workers, deploy domestic supply chains for every bolt and cable, and finish projects that would take private companies years, in months. It's a reflection of how China builds, fast, centralized, and with a clear long-term plan. From above, the Fuyang complex looks like a technological coral reef, a living organism that expands, adapts, and powers entire regions. Yet despite its scale, it remains silent, producing clean electricity day after day, invisible from the headlines that focus only on wind turbines or deserts filled with panels. But floating solar might be the quiet revolution no one saw coming. It's not just a solar farm. It's a blueprint for how energy infrastructure can coexist with nature instead of competing with it. Across the Pacific, a different story was unfolding. In June 2023, a ribbon cutting in New Jersey marked a proud milestone for American renewable energy. Local officials gathered by the water's edge as 16,510 solar panels floated quietly across the surface of a reservoir in Milburn Township. The project was called Canoe Brook, built by NJR Clean Energy Ventures in partnership with New Jersey American Water. At 8.9 megawatts, it became the largest floating solar plant in North America, big enough to supply about 95% of the nearby water treatment plant's power demand. It was a victory for local innovation. But compared to China's vast solar lakes, it felt like a postcard from another era. China's Fuyang array generates about 700 gigawatt-hours a year. Canoe Brook produces less than 10. So why is the US lagging behind? The problem isn't technology, it's bureaucracy. Most of America's ideal floating solar sites are reservoirs, quarries, or water treatment ponds, many owned by federal agencies like the Bureau of Reclamation or the Army Corps of Engineers. Each site comes with a maze of regulations on navigation, wildlife, recreation, and water rights. To install panels on a federal reservoir, developers must obtain multiple environmental clearances, a process that can stretch for years. In China, a single state-owned developer can coordinate the entire chain, from permits to financing to grid access, under one umbrella. In the US, each stage involves a different agency, and sometimes a lawsuit. Even when a project clears all the hurdles, financial risk remains. Floating solar costs slightly more per watt than ground-mounted systems due to anchoring and waterproofing. Banks and investors are cautious because few large projects exist to prove long-term performance. Without standard contracts or national guidelines, each project becomes a custom case, adding months of paperwork and legal review. Despite that, interest is growing. A handful of smaller floating arrays have appeared in California, Florida, and Massachusetts, mostly pilot-scale installations between 1 and 5 megawatts. These projects show that the technology works, but scaling them remains difficult without unified rules. In 2024, researchers at the National Renewable Energy Laboratory, or NREL, published a startling analysis. They found that if floating solar panels covered just a portion of the nation's reservoirs, they could produce up to 1,476 terawatt-hours of electricity each year, enough to power around 100 million homes. That's nearly one-third of America's total annual electricity use. Yet despite this massive potential, no large-scale floating solar project has been built on any federally managed reservoir. Instead, the U.S. focuses on small municipal or privately owned water bodies, where permits are easier and local control allows faster approval. The irony is striking. The country that once led in renewable innovation now trails in deployment. China has built gigawatt-class floating farms in less than a decade. The U.S., with all its engineering talent and resources, has not yet reached 10 megawatts on a single site. But the gap isn't just about size, it's about momentum. While China refines designs and scales manufacturing, the U.S. is still deciding how to build and who should be allowed to build. The result? China is already exporting its floating solar technology to Southeast Asia, Africa, and the Middle East, while America's best opportunities remain locked behind regulations and studies. Still, the story isn't over. Change often begins with comparison, and the sight of a 650-megawatt floating city on the other side of the world has begun to shift opinions in Washington and state capitals alike. Because if a coal pit in Anhui can become a solar lake, what's stopping a reservoir in Arizona or Texas from doing the same? The scale gap between China and the United States is more than an engineering story, it's a reflection of power. China's floating solar boom is part of a coordinated national strategy. State-owned giants like China Three Gorges, Huaneng, and CHN Energy control the full supply chain, from float manufacturing to module production and grid integration. That's why they can build hundreds of megawatts in months, while others debate permits. For Beijing, floating solar isn't just clean energy, it's industrial diplomacy. Each new project strengthens domestic companies that will soon export their expertise across Asia, Africa, and the Middle East. Meanwhile, analysts at Wood Mackenzie project that Asia-Pacific will account for 9 of the 10 largest floating solar markets by 2033, led by China, India, and Indonesia. In contrast, the U.S. has technical potential far beyond what's been built, yet remains locked in pilot mode. The difference isn't sunlight. It's coordination, scale, and political will. And as the rest of the world looks for models to follow, China's shimmering power islands send a clear message. The race for renewable dominance isn't on land anymore, it's floating. China's next frontier pushed floating solar into the open sea. In late 2024, CHN Energy began connecting the Kenli 1 gigawatt offshore project in Shandong province, the world's first floating solar farm built for open sea conditions. Steel truss platforms rise above the waves, supported by piles drilled deep into the seabed. Each section sends power ashore through 66 kilovolt submarine cables, built to endure saltwater, tides, and typhoons. It's risky, expensive, and completely new. But if it works, it could unlock thousands of square kilometers of shallow coastal water for clean energy generation. The United States watches with interest and concern. NREL studies show the same potential on American reservoirs, yet none have moved beyond research. Permits linger. Investors hesitate. Meanwhile, China is already testing marine-grade floating grids and exporting that technology abroad. The contrast is striking. China builds, the U.S. debates. And every year the gap widens. Still, the race isn't over. New standards from NREL and state-level projects hint that momentum is finally shifting. If even a fraction of America's reservoirs were used, the results could be transformative. But for now, one truth remains clear. The world's largest solar farms no longer stand on land, they float.